Now we are going to solve previous year GATE and IES questions on turning on of thyristor. This is really important because questions has been repeatedly asked in every 2 or 3 years from this topic. So you need to go through this lecture very carefully. You need to understand all the concepts and to know more about the concept behind these questions. You need to refer my lecture number 6, that is silicon control rectifier. So let's start the video. Now see this question that has been asked in GATE 2004. In this question, this circuit is given and question says that triggering circuit of SCR is given. SCR requires 10 milliampere to turn on. Find the value of R to turn on SCR. Here VB is given as 12 plus minus 4 volt. So here we have to find the value of R. It is simply given by VB by, and what is current through this SCR, that is 10 milliampere, so 10 into 10 to the power minus 3. Okay, now to reliably turn on the SCR, this voltage VB must be minimum. Okay, so what is this VB? This is 12 plus minus 4, so it must be equals to 12 minus 4, okay, upon 10 into 10 to the power minus 3, and that is simply equals to 8 upon 10 into 10 to the power minus 3. So when you solve this, you get that is equals to, this 10 will cancel, go 80 ohm. Okay, so 80 ohm is answer. This is very simple question and this has been asked in GATE 2004. Now we will solve the question that has been asked in ES 2001 and a similar question has been asked in ES 2012. So this circuit is given and it says that latching current is equals to 4 milliampere and we have to find the minimum gate pulse width to turn on NCR. So we know that to turn on the NCR, latching current must be equals to anode current. First thing is this, and second thing is we have to apply the gate pulse till the anode current reaches the value latching current, because when we apply the gate pulse, then anode current through this SCR start increasing, but when this increasing anode current reaches the value IL, then at that time we can easily remove the gate pulse, because once this value is reached, this threshold 4 milliampere is reached, then gate loses its control. After that, even if we remove the gate pulse, then SCR will remain turn on. So okay, so these are the concepts of SCR. So after knowing this concept, now we can easily solve this. So what is voltage across inductor? V is equals to L di by dt. Okay, L di by dt. What is the significance of this di? Di, that we require that di must change from 0 to 4 milliampere, or we can say that change in current must be equals to 4 milliampere, that is equals to latching current. So desired value of di is 4 into 10 to the power minus 3. Now what is dt? The significance of dt is the time for which gate pulse is applied, because this is the time during which anode current changes from 0 to 4 milliampere. So this time gives the width of gate pulse and we have to find this time. Here voltage is given 100 volt. Okay, this is 100. That is equals to, what is inductor? That is given 0.1 Henry. And what is change in inductor? Change in inductor current, or we can say that change in anode current, because inductor and this SCR are in series. That's why IL is equals to IA. Okay, so that is equals to 4 into 10 to the power minus 3 and divided by dt. So on solving this, we get dt is equals to 0.1 into 4 into 10 to the power minus 3 by 100. Okay, so on solving this, we get this 10 to the power minus 6, so 4 microsecond. So 4 microsecond is answer, or 4 into 10 to the power minus 6 second. Now we will solve the question that has been asked in ES 2009. For an SCR, the gate cathode characteristic has a straight line slope of 140. For triggered source of 20 volt and allowable gate power dissipation of 0.5 watt, what is the gate source resistance? Okay, here these three values are given. So to solve this circuit, you must know the equation of gate cathode circuit. You must remember this equation, or I can say memorize this equation. Vs is equals to Vg plus IGRs. Okay, it is simply given by applying KVL in gate cathode circuit, where Vs is the triggered source voltage, or we can say that it is gate source voltage. And what is Vg? Vg is gate cathode voltage. And this is gate current, and this is, what is Rs? Rs is the source resistance, gate source resistance. Okay, and Ig is the gate current. Okay, and this IGRS is the voltage drop across gate. So if you want to understand, then you can understand this as, okay, so trigger circuit is like this. So this plus minus is gate cathode voltage. Okay, and this is Vs. Okay, and what is IGRS? This is suppose Rs, then this is IGRS. Okay, so if we simply apply KVL in this loop, then we will get this equation. Okay, now see the question. Here question says that gate cathode characteristic has a straight line slope of 140. Gate cathode characteristic means, here characteristic means Vi characteristic. And what is the slope of Vi characteristic? That is equals to V upon I. And for gate cathode circuit, V is equals to Vg and I is equals to Ig. Okay, so there this is given as 140. And here it says that the allowable gate power distribution of 0.5 watt. It means Vg into Ig is given as 0.5 watt. Okay, now here first we will find the value of gate current. Simply divide this. Okay, we get Vg Ig upon Vg slash Ig is equals to 0.5 by 140. On solving this, we get so this Vg will cancel out. We get Ig square, that is equals to 0.5 by 140. When you solve this, you will get Ig is equals to 0.05 ampere. Okay, so this Ig is 0.05 ampere. Now what is Rs? So simply rearranging this equation, we get Rs is equals to Vs, take this Vg minus Vg by divide by Ig, so we will get Ig, and that is equals to, what is Vs? Vs is given 20 volt. Okay, gate source voltage is 20 volt, that is trigger source. So put 20, and what is Vg? Vg is simply equals to 140 Ig. Okay, from this Vg is equals to 140 Ig. So 140 Ig upon Ig. And what is the value of Ig? That is equals to 0.05 ampere. So putting this value of Ig here and putting this value of Ig here, what we get? We get
Rs is equals to 195 ohm. So this 195 ohm is answer.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.